Hi, today we are going to learn how to find the area of a curve that is bounded by the x-axis or the y-axis. Now let's consider this graph y is equals to f of x. Now our objective for the first part of the lesson is we want to find this area. Alright, this particular area here. Okay. Now before that, let's find the area of one particular strip. So area of one strip, area of shaded strip will be equals to, now let's say we cut this strip so small, alright, and this distance here is dx. Now, then what is this height here? This height here is given by f of x. Alright, so it will be f of x dx. Now, whatever this value of x here, alright, you put f, let's say this is 3, alright, it will be f3, alright. Because the area, the strip is so tiny that this, to you, it looks like a rectangular strip instead of a trapezoid, instead of having a shape of a trapezium. Can you imagine that? Now, if you cut the strip so big, alright, if the strip is so huge, alright, but now imagine you cut it so small, alright, so tiny, that this one is almost very close to being a rectangle, alright, and this value here, right, whatever f takes, alright, let's say f takes the value of c, then it will be, this height here will be fc, okay? Now this height here will be fc, and then this part here will be dx, okay? Now, so what is the area of this whole this whole shaded part here? All right, this purplish shaded part, okay, this whole thing. All right, so area, now total area, all right, total, I call it total. Okay, now what would that be? Now it will be f of a times dx, okay, plus f of a plus dx times dx plus f of a plus 2dx times dx, so on and so forth, okay, until I reach b, okay. Now that we can rewrite it in this form, it will be integral from a to b f of x dx. Now integration means the sum, alright, you sum from a to b, all this small strip, that is what it means. Alright, you are finding the area under the graph, alright, that is bounded by these two lines, x equals to a, x equals to b, and the x-axis. Now let's move on to how are we going to find the area of this part. Alright, this is our required area, okay, this part. Now how to find this area? Now there's a couple of ways, or I will introduce you to you using the horizontal strip. Earlier on we used the vertical strip, okay. Now, so I would say area of horizontal strip, area of horizontal strip will be equals to, now this is dy, all right? This distance here is dy. You cut the strip so tiny. Now what is this distance here will be x dy. Okay. Now so let's say if this y coordinate is c and this is d. Okay. So total shaded area, all right, area total or total required area. This is the area that we are talking about. Okay, will be equals to summation from the lower limit from C to D, all right, of x dy. Okay, now next we will apply what we have learned to a question. In this example, you are asked to find the area that is bounded by this graph with the x-axis and this line x equals to 0 and x equals to 4. So this is the required area. Now let's find the area of a vertical strip first. Now so this, imagine this is dx. And then this height will be given by f of x. So area of a vertical strip is f of x dx, or you can put y to replace f of x. Now you are summing all the vertical strip from 0 to 4. Integration from 0 to 4. So this is your required area. Now what is f of x? F of x is x squared. So 0 to 4 x squared dx. And then you will get x cubed over 3, and you put the limits from 0 to 4. Let's work that out. 64 over 3 unit square. Okay. Now next, you are asked to find this shaded area. Now how can we find this shaded area? We can use the area of a rectangle minus the yellow shaded area. What is the area of the rectangle? Now x is 4. What is the value of y? Alright, this coordinate here. Now when x is 4, this will be 16. Alright. So I call it pink shaded area. Now this area of the rectangle is 16 times 4, all right, minus this yellow shaded area is 64 over 3. Okay, now this you will get 64. Now then you've got to change to common denominator, so times 3 minus 64 over 3. And for that you will have 128 over 3 units square. Now the objective for me is not to show you that you can do this, all right, you can minus, but I want to introduce to you the horizontal strip and see if we do the horizontal strip, will you get the same answer as this? All right, let's begin. Now let's find the area of a horizontal strip. Now this part is dy. dy is a small change in y, so you have a tiny little thin horizontal strip. So this, what is this distance here? This distance is x. So area of one horizontal strip is x times dy. So you are integrating from 0 to 16. So 0 to 16. Alright, so this is the pink area. Pink area. Okay. Now what is x? X is root y. You have to express x in terms of y here. So you have from 0 to 16 root y. Now you have to express this in terms of x in terms of y because you're integrating with respect to y. So it has to be in terms of y. So this is from 0 to 16 x to the power of half dy. So this will be x 3 over 2, then here will be 2/3, and then from 0 to 16. Okay, now what will be your answer here? Now you put 16 inside, so square root of 16 is 4. Then you cube it, is cube of 4 is 64. 64 times 2 is 128. So the answer is 128 over 3 units squared. Alright, there you go. You have the same answer. In the next video, I'll be showing you how to find the area that is bounded by 2 or more curves. These are 2 typical examples. I will put the URL in the description below once we are done with that. Thank you very much and have a nice day.